hello, be able to find the nth term of quadratic sequences. Here are the first 5 terms of a sequence: 3, 8, 17, 30, 47. Find an expression in terms of n for the nth term of this sequence. So as with linear sequences, we need to figure out what the sequence is going up in. So it goes up 5, and then 9, and then 13, and then 17. Now, obviously, it's not a linear sequence because this isn't going up in equal amounts, so we need to find the second difference. And the second difference is going to indicate the coefficient of the n squared. Now, what we need to do is we need to divide this second difference by 2. 4 divided by 2 is 2, so it's 2n squared, which we now know is part of our sequence. And what we're going to do with this 2n squared is we're going to subtract 2n squared from our original sequence. The values for 2n squared are double the square numbers. So 1, 4, 9, 16, 25. Doubled will be 1 doubled is 2, 4 doubled is 8, 9 doubled is 18, 16 doubled is 32, and 25 doubled is 50. And we're going to subtract that from our original sequence to see what we're left with. So 3 take away 2 is 1, 8 take away 8 is 0, 17 take away 18 is minus 1, 30 take away 32 is minus 2, 47 take away 50 is minus 3. Now, here we have a sequence with a common difference. The common difference here is minus 1, so we would write minus 1n, but we don't write minus 1n because it's not polite, so we just write minus n. Now, at this point, we know minus n is part of the sequence, so we're going to take away the sequence of minus n. Now, you need to be careful with your signs here. The sequence of minus n is minus 1, minus 2, minus 3, minus 4, and minus 5, because the sequence for n would be 1, 2, 3, 4, 5. Minus n is obviously the negative version of that sequence. And we're going to take it away from what we have left. Now, you've got to be careful here because it's going to be a minus minus, which always equals a plus. 1 minus minus 1 is 2. 0 minus minus 2 is 2. Minus 1 minus minus 3 is minus 1 plus 3, so that's also 2. Same case here, minus 2 minus minus 4 is also 2. Minus 3 minus minus 5 is also 2. So that we know now that plus 2, positive 2, is part of our sequence. So the overall nth term for this sequence is 2n squared minus n plus 2. Now we have another sequence below, and again we're going to find the nth term of this sequence. We're going to look at the differences. So the first difference is positive 1, followed by 3, followed by 5, followed by 7. So again, you can see that it's not linear because we haven't got a common difference. So our next difference is 2, 2, and 2. So this indicates that it's a quadratic sequence. We half the second difference. We divide it by 2 to find the coefficient of the n. 2 divided by 2 is 1. So it would be 1n squared, but we don't write 1n squared because it's not polite. So n squared is part of our sequence, and what we're going to do is we're going to subtract that from our original sequence. N squared is literally just the square numbers 1, 4, 9, 16, and 25, and we're going to subtract that from our original sequence. So minus 1 take away 1 is minus 2. 0 take away 4 is minus 4. 3 take away 9 is minus 6. 8 take away 16 is minus 8. 15 take away 25 is minus 10. Now you can see here that this sequence goes down in 2, and a sequence that goes up in 2 would be 2n. a sequence that goes down in 2 would be minus 2n. So now we know that minus 2n is part of our sequence. And what we're going to do is we're going to subtract that, again being careful with the negatives. The minus 2n sequence is actually exactly what we have left. And just to prove that we don't need anything else for this sequence, if we subtract minus 2n from our leftovers after subtracting n squared, minus 2 minus minus 2 is 0. Minus 4 minus minus 4 is also 0, and you get the idea that it's going to be 0, so we don't need to add 0 or take away 0. Our nth term for this sequence is simply n squared minus 2n. Hasta la pizza, arrivederci, so long, goodbye, au revoir. See you next time.